Good evening, everyone. I hope I'm audible to all of you. Please confirm, am I audible to all of you?
Yes, sir, you're audible.
Yeah, thank you. Myself, Dr. Rao, working at the Gujarat National University, Gandhinagar. I would like to thank Professor S. Shantakumar, Director, Gujarat National University, Gandhinagar, for the entire support. This particular program, that is 1 week national level online faculty development program on using advanced tools and techniques for quantitative and qualitative analysis. Specific focus on JOMOV and NVIVO. So we are going to have 7 days program, starting with from 6th September, that is from today, until 12th. We have divided this particular 7 days program into 2 components. Starting from 6th to 9th, we are going to have quantitative data analysis. Now coming to the JOMOV, as I mentioned, it is a free and open source software. Some of you might have seen SPSS. You might have used, some of you are good at SPSS. Some of you are good at R software. Some of you might have used JASP software. So there are a good number of softwares, alternative softwares that are available. Now coming to the JOMOV, why one has to go for it? JOMOV is a free and open source software. It is not required for you, for your university, to spend lakhs of rupees to buy SPSS. So that is the best part of JOMOV. We are going to talk about it from 6th to 9th September. That is the next 4 days. We are going to work on JOMOV for quantitative data analysis. From the 10th onwards, 10th September to 12th September, we are going to discuss about qualitative data analysis. That is with the help of NVIVO. Now, when it comes to the qualitative data analysis, we have different kind of softwares. Like NVIVO is one of the best software. Some of you might have used Atlas TI. There is another good software. Third one, we also have Max QDA. Max QDA is another software. There are certain free softwares which are available, but the problem with other software is that we have very limited features. So we realized these are the 2 important softwares which are considered as the topmost important and having good number of features. So we thought of creating, sharing knowledge and learning from each one of us. So that was the main intention. I thank Gujarat National University. I'm proud to be part of this particular university. And I also thank Law Teachers India, especially Dr. Kalpesh Kumar Gupta. He was not able to talk, but definitely will come back after some time, maybe at the end of the session. Yeah, he's here. Dr. Kalpesh is here. So I would like to thank Dr. Kalpesh Kumar Gupta. And lastly, I also thank all the participants, those who joined from different parts of India. We got a really good number of respondents across the disciplines, across the universities, and from across the different states. So I thank each one of you for joining this program. I'm sure, at least for the people, those who are at the stage of early career, definitely it can be a good introduction part. The people, those who have good amount of knowledge, good amount of experience in statistics and using quantitative data analysis, I request you to feel free to share your knowledge. Try to add it at the end of the sessions. We are going to have question and answer sessions. So it is going to be a completely hands-on practice. From tomorrow, we are going to have JOMOV. We are going to install JOMOV as a part of the session. And I'm going to share you certain data sets. So we practice it. It's going to go simultaneously. It's not that I'm going to discuss something and you are going to listen. I request you all from tomorrow, please join with your laptop or PC if it's possible. So with this brief introduction, I would like to start today's session. As a part of day 1, I'm going to discuss about basic concepts of quantitative data analysis. Before starting the session, I would like to thank various scholars for their contribution in terms of academic, in terms of research, in terms of sharing their knowledge. I have used several papers, their data sets. I tried my best to give the acknowledgement wherever possible. And whether I have given acknowledgement or not, I just want to thank each one of them, whatever the documents that I have referred as a part of this particular session. Now, let me start understanding the concept. Imagine that you have completed your data collection. So this is a tool that you have it, title of the study. Questionnaire on inclusive education for students with disabilities in higher education institutions. Just imagine that this is your research study, or imagine that you have collected your data. I'm going in reverse way. Generally, people talk about hypothesis, how to frame hypothesis and all. I'm trying to come up with new way today. So we have completed data collection. As you can see that we come up with 20 questions. Some people will come up with 50 questions. Some people will come up with 100 questions. It depends on the study. It depends on the course that you are conducting it. One can able to see 20 questions, 30 questions, 40 questions, or maybe, for example, if you're a PhD scholar, you might be coming with around 60 to 70 questions, or maybe different types of research tools. Now, the question comes here without understanding the statistics, without understanding anything. Just randomly, I prepared my proposal. My proposal got approval from the doctoral committee members. Okay. Now, I started realizing that what kind of data analysis I had to do it. Now, the question comes here, how to analyze the data, how to take the call. Let's take, for example, when I was in PhD research, I was thinking, I'm not good at English. I don't know how to write good analytical skills. Neither I'm good at English nor good at statistics. How to go for it? So I was thinking that whether I'm good at statistics, whether I'm good at English, I'm thinking, but I'm not looking at it. What are the purpose of the study is all about it. Now, whether it is quantitative study, whether it is qualitative study, whether it is mixed methodology, it all depends on the purpose. Based on the purpose, you're going to come up with your research questions, maybe a research hypothesis, right? So your purpose of the study decides whether you're going to have quantitative study or qualitative study. Now, coming to this particular question here, we have quantitative research. Now, when it comes to statistics, you have collected data. Right now, data is there with you. Now, I want to go for analyzing the data. Now, within the statistics, as we are going with a completely quantitative data analysis, there are two types of statistics. One is descriptive statistics. The second one is inferential statistics. As the name itself suggests, descriptive statistics means you are going to describe the data. I'm sure as a part of our 8th standard, 9th standard, 10th standard, we all have done with measures of central tendency, measures of dispersion, like mean, mode, median, like a range, like interquartile, first quartile. We have different kind of statistics. Descriptive statistics we have done as a part of 8th, 9th, 10th standard. The main object of descriptive statistics is to explain what you have observed it, what you have seen it. The main object of this particular descriptive research is to collect the data from the small sample or the total population that is available. Basically, it is a small sample, and you are trying to describe it. Whereas when it comes to inferential statistics, the main objective here is to come up with some kind of generalizations. You can't study whole population. You can't study particular entire community. You can't study entire university. But I want to come up with some kind of generalizations. I want to come up with some findings. I want to come up infer the results. So as a part of inferential statistics, we are going to come up with framing the hypothesis. For using the inferential statistics, for coming up with inferential statistics, one has to frame the hypothesis. Whereas when it comes to descriptive statistics, you're going to come up with your data analysis. You're going to use mean, median, mode, and you're not concerned about generalizing your research findings. Okay. Whereas when it comes to inferential statistics, one has to see what is the hypothesis that you're going to frame. What kind of hypothesis that you're going to frame? What kind of sample that you're going to choose? Is it going to be probability sampling? Is it going to be non-probability sampling? Within probability, what is the sample size? What is the homogeneity of the variance? There are so many terms we have. The main point that I want to highlight here is that as a part of inferential statistics, we are trying to come up with infer. For example, you are selecting small sample from the whole population. And what are the findings that you're going to come up? You start concluding, you start generalizing your findings with the rest of the population. So in that case, one has to go for framing the hypothesis. Now, coming to the inferential statistics, let me briefly summarize it, what we discussed in the previous slide. There are two types of statistics. Descriptive statistics, the main objective is to describe the data with the help of measures of central tendency, measures of dispersion. Whereas when it comes to inferential statistics, we'll frame the hypothesis, we'll go for various statistical tests. Now, I'm going to talk about within this inferential statistics, what kind of tests we have. I'm just presenting very few statistics here for the sake of understanding. We have t-test, that is nothing but comparison-based test. Means if you want to understand difference between teachers and students, or if you want to see the difference between male and female, urban area, rural area, higher secondary students, university students, wherever possible, if I'm trying to compare between different groups, between different individuals, right? Now we are going to have comparison-based test. Within t-test, we have one sample t-test, independent sample t-test, paid sample t-test. Every test has its own purpose. But the main object of entire t-test is the comparison between different groups, different individuals, different institutions. So basically, you're trying to compare it as a part of t-test. Now, we have one more as a part of the comparison-based test, ANOVA test. Within ANOVA, whenever we have more than two groups, like for example, as a part of t-test, we have one of the test is independent sample t-test. If I'm trying to compare the difference between, let's take for example, one of the examples here, there is no significant difference in sentencing outcomes between male and female defendants in Indian criminal courts. I'm just repeating again. As a part of comparison-based test, the hypothesis that I framed for independent sample t-test. Now here I have gender. In gender category, male, female is the one. We have two categories. And here I'm looking at sentencing outcomes. Sentencing outcomes is one variable. Now, if I'm having more than two categories, like for example, male, female, and we also have transgender, in that case, I'll go for ANOVA test. So t-test and ANOVA both are comparison-based test. So it depends on the number of variables that you have that differentiates. Next one, regression. Regression analysis is basically try to understand cause and effect relationship. In the t-test, in the comparison-based test, we are only comparing it. Whereas when it comes to regression, we're trying to see cause and effect relationship. Let's take for example, there is no significant relationship between independent variable, like for example, type of dispute, mediator experience, number of sessions, willingness to cooperate. Now, these are all independent variables. I just want to know, let me put it in simple example here. The price of product and product quality ratings have no significant effect on sales. For example, if I'm spending for this particular workshop, if I'm spending around 5,000 rupees as a part of advertisement, and what kind of impact is having on number of registrations. So if I want to see cause and effect relationship, for example, level of education as a part of our participants, there are professors, there are associate professors, we have assistant professors, we also have research scholars. I just want to see the level of position that you have it. The level of position and your annual income. The level of position and your annual income. Our number of years of education and annual income. The person who completed PhD, what is his or her annual income? So if I'm seeing cause and effect relationship, one is go for regression test, we have it. In the similar line, we also have correlation test. The main difference between correlation and regression is that as a part of correlation test, one can able to see direction, whether it's a positive correlationship, whether it's a negative correlationship, and what is the strength. It can't tell what is the cause and effect relationship. Okay, so we have basically different tests. Right now, you don't need to worry about it. You don't need to see how to frame hypothesis. The main objective for me here to tell you that there are inferential statistics. Within inferential statistics, we have comparison-based test, relationship-based test, cause and effect relationship-based test. We also have chi-square. So there are so many tests. Every test we are going to choose. If I'm going to go for chi-square test, what is my purpose? I want to see association. If I'm going for t-test, I want to see the comparison. If I'm going for regression, if I want to see cause and effect relationship. If I'm going for correlation, I want to see just only, is there any relationship between demand and supply? The person who is buying eggs, whether he or she is going to buy a bread packet or not, especially when it comes to market. So the people are buying eggs or bread. So what is the correlation we have? There is no anything like cause and effect relationship. Just you are estimating there can be some kind of relation, right? So we have different tests as a part of inferential statistics. Now the point here is that first one, we have decided that there are different types of statistics, descriptive statistics. Second one, inferential statistics. As a part of descriptive statistics, we have mean, mode, median. As a part of inferential statistics, we have t-test, we have ANOVA regression correlation. Now the problem comes here, when to go for regression, when to go for t-test, when to go for chi-square test, right? Now you cannot simply choose blindly that I want to go for regression test, I want to go for chi-square test. There are certain assumptions one has to fulfill. As a researcher, one has to fulfill certain assumptions. If you're able to fulfill certain assumptions, we call them as a parametric statistics. If you're able to fulfill certain assumptions, every test has its own assumptions. There's nothing like these are the only two assumptions can be applied for every test. Every test have its own unique assumptions. If you're able to fulfill that particular assumptions, that will be known as parametric statistics. If you're not able to fulfill the assumptions, that will be known as non-parametric statistics. Now, what are the assumptions? What are the assumptions? Right now, I'm presenting 4 basic assumptions. It is not for any specific test. These are the 4 basic assumptions can be applied for any test. But other than this 4, there are few more assumptions for every test. Let me start from the bottom. Levels of measurement. Levels of measurement. I don't think I'm going to add any new knowledge to many of you, but for some of you it may be refreshing. But I'm looking at the scholars, research scholars. I'm looking at the people, those are at the early stage of their career. Coming to the levels of measurement, as you all know that we have around 50 questions, 30 questions as a part of our research tool. Some of you might be having 10 questions. Some of you might be having 50 questions. But at the end of the day, we are going to keep entire research question. I'm talking about quantitative research tool. If you're going to prepare structural research tool, if you're going to have quantitative research tool, if you're going to keep the entire data, it can be 20 questions, it can be 30 questions under 4 categories, 4 levels of measurement, 4 different levels of measurement. What are they? We can able to divide into 2 categories. One is qualitative, second one is quantitative. We have nominal data, ordinal data, interval data, ratio data. As a researcher, as a part of PhD, you might be having 70 questions, or you might have 15 questions. But we are going to categorize the entire questions, whether it's 20 questions, 50 questions, under 4 levels of measurement. There is nothing but nominal data. What are the data we are going to categorize in terms of classifications, in terms of labels? Like, for example, gender, male, female, transgender, or any other category that we are going to have it. It is known as nominal data. Looking at your eye color, some of you might be having gray color, some of you might be having white and black. So, for example, all of you are having smartphone. Looking at your smartphone, I can categorize my participants. How many of them are using, how many of you are using smartphone, Samsung, LG. So there are different kind of companies we have. So we are categorizing data in the form of companies. We are labeling them. That is called nominal data. Second one, we have ordinal data. One can able to see in every research tool, like education qualification, like SSC, intermediate, UZ, PZ, PhD. For example, don't take it other way. Imagine that I'm taking all of your height. I'm converting this height into qualitative data, like low height, medium level height, or I can say that tall. Or looking at your CGP, looking at your marks, A grade, B grade, C grade. So whatever the data, if I'm putting in the form of positioning, if I'm putting in the form of ranking, that is known as ordinal data. We also have one of the most important tool, Likert scale. Generally, we use it whenever we are going to construct any scale. Mostly we'll coming with a Likert scale, like strongly agree to strongly disagree, strongly disagree to strongly agree. It can be 5-point Likert scale, it can be 7-point Likert scale, it can be 9-point Likert scale, or it can be 11-point interest. So we have different kind of scales we have. Now, some of you will agree with me that there is a lot of debate is going on. Likert scale, right now we consider this as an ordinal data. Majority of the scholars, they consider Likert scale as an ordinal data. Similarly, same amount of scholars also say that Likert scale, we call it as a interval data. Likert scale, we also call it as a interval data. So choice is there for you. So nobody can say that why you mentioned it as a ordinal data, why you said it's an internal data. So we don't have proper authentication, proper authority to say that this is a ordinal data, this is a Likert scale data. But majority of them use Likert scale as a ordinal data. I hope I'm able to, is it clear? Is going well so far? Shall we go ahead? Okay. Now coming to the interval, wherever we have differences between one interval to another interval. So one can able to see that as a part of the interval, one can able to see continuous data. For example, if you ask, what is your height? What you say your height? My height is 5.6, 5.8. What is your weight? My weight is 68, 58, right? But if you ask someone, how many children do you have? They say that 2 children. So we all have continuous data. We also have discrete data. Discrete data means whole number. How many children do you have? I have 2 children. What is your annual income? My annual income is 5 lakhs. So this is called discrete data. Continuous data means if I'm putting that 5 lakhs to 20 lakhs, or maybe if I say that 5.6 is my height, 58.9 is my weight, right? So we have different kind of continuous data as well as discrete data. We have it. I'll be discussing this particular slide once again tomorrow at the time of entering the data in Jamovi. As we are going to work manually, we are going to discuss this particular part, how to enter the data manually. If it is nominal data, if it is ordinal data, if it is continuous data, if it is discrete data, how to enter it. So we'll discuss step by step with the help of the software in tomorrow's session. After understanding the levels of measurement, there are 4 types of levels of measurement: nominal data, ordinal data, interval data, ratio data. One more important point here is that nominal data and ordinal data, we call them as a categorical data. We call ordinal data and nominal data as a categorical data or as a qualitative data. Somebody can ask me, we are conducting quantitative research. We are designing the research, design tool is quantitative research. We are already given coding. Then how we are going to call? It is a qualitative, because nominal data, we are going to classify in terms of specific labels. Similarly, ordinal data, we are going to put in terms of ranking, in terms of positioning. So both not having any numerical numbers. We can't quantify. You're going to quantify them, but it is a categorical data. It is a qualitative data. Whereas when it comes to interval and ratio data, it is known as quantitative data. It is also known as metric data. It is also known as scale data. It depends on the software that you use it. For example, some of you might be knowing it, SPSS. If you open the SPSS software, it will show you interval and ratio as a scale data. Interval and ratio as a scale data it will show. Means it is considering them as a metric or scale data or quantitative data. Now, next important point at the time of choosing the statistics, random sampling. I'm not going to talk about what is sampling and all, but in generally, we all know that we have 2 types of sampling techniques: probability sampling, non-probability sampling. Probability sampling means each and every respondent is having equal chance of being selected in your study. Means randomly you're going to pick your respondents after finalizing the list or what are the directories that you have it, what are the sample frame that you have it. You're going to pick certain respondents based on certain sampling techniques. Within probability sampling technique, we have simple random sampling, systematic sampling technique, stratified sampling, cluster sampling, and there are also certain names like multi-stage sampling. So we have different types of probability sampling technique. Similarly, we also have non-probability sampling technique like purposive sampling, quota sampling, convenience sampling. So we have different kind of probability sampling, non-probability sampling. Now, when it comes to going for statistics, especially when it comes to going for conducting hypothesis test, framing hypothesis and going for test, how we have collected data? You must have collected data by using random sampling technique. It can be simple random, it can be systematic sampling, it can be cluster sampling, but you must have collected data by using probability sampling technique. If you have collected data by using non-probability sampling technique, we cannot go for parametric statistics. As I mentioned it, if you are able to fulfill the assumptions one can go for parametric statistics. If you're not able to fulfill the assumptions, we have to go for non-parametric statistics. The difference between parametric and non-parametric is that parametric test considered as more robust, more reliable as compared with the non-parametric test. So that is the only reason. Otherwise, for every parametric test, we have one alternative test. If I talk about t-test, if I'm not able to fulfill any of the assumptions here, I can go for simply non-parametric test. I can complete my study, I can publish it. Only thing is, my findings as per the research statistics, it is not much reliable as compared with the parametric statistics. So the point here is that if I'm collecting data by using probability sampling techniques, I can go for parametric statistics. Second one, third point is that normality distribution of the data. I just want to put it a simple manner. Tomorrow we are going to test normality test with the help of the data. Today I'm just introducing the concept here. Let's take for example here. I hope you are able to see my screen, my cursor. As you can see here, this is a bell-shaped curve we have it. This is a bell-shaped curve. It means this is the data that I collected. Just imagine that I have collected data from 100 people. In order to test whether my data is distributed normally or not, we have so many tests. Like some of you might have heard about it, kurtosis, skewness. We also have histogram to present the data in the form of normality distribution of the data. We also have Sperry-Wilkie test. So there are QQ plots, normal QQ plots, leaf and seed. There are so many tests are available. But as a researcher, you can choose one of the tests and understand whether your data is distributed normally or not. Now, from tomorrow onwards, we are going to conduct normality test as a part of parametric test. If you want to use parametric test, you should know whether your data is distributed normality or not. Now, the question is, what is meant by normality? Let's take, for example, I'm very happy to talk about my institute, Gujarat National University. Say, for example, imagine that I'm taking 5 candidates of my GNLU passed out students. Okay, 5 candidates, I'm taking their annual package. Hypothetically, I'm taking their annual package. Like, for example, candidate number 1, he's hanging around 80,000 rupees per month package. Okay, 80,000 rupees per month package. Candidate number 2, 90,000 rupees package. Just 1 minute. We have 80,000 plus 90,000 plus again third candidate got around 80,000 and third candidate 90,000 and fifth candidate he became as a film actor or a politician or cricketer. What happens is he's getting around monthly. He's getting around 2 crores rupees. Don't go by face value. Just roughly I mentioned some figures. Don't count numbers and all. Okay. Now the point here is that if I take the normality distribution, means what I'm going to do, I'll count 80,000 plus 90,000 plus again 80,000 plus 90,000 divided by 4. So I'll get average package of GNLU students. 80, 80, 60, 60 plus 180. A very poor max. Okay, just imagine that around 3 lakhs rupees altogether. 3 lakhs divided by 4. How much it will come? 85. Now I can say that on average, my GNLU students are getting monthly package 85,000 rupees. In the first case. In the second example, I have included number candidate as a 2 crores. Now, if I'm going to count 2 crores here, it is going to completely change the entire picture. Instead of showing 75,000 or 85,000 monthly package, it will show around 50 lakhs monthly package. I can't rely on these particular findings. The finding that I'm giving it, I can't rely on it because this is not a correct figure. Why is not correct figure? Because what is the difference between 80,000 to 2 crores? The difference is very huge. The difference between 80,000 to 90,000 hardly 10,000. It is a 10,000 difference. And again, we have 10,000 difference. Again, we have 10,000 difference. So annual package, monthly package is 70,000 rupees, 75,000 rupees package. If I divide it by 4 members, But if I add this, this is the deviant. This is outlier. This is completely outlier, means where is 80,000, where is 2 crores. So we can be able to see a lot of gap. So just because of this particular outlier, just because of there is a deviant from the main data, it is going to affect our major findings of our study. The kind of findings that you are going to come up with, they are not reliable. Now, the point here is that if your data is distributed normally, it means, for example, as you can see here, right now, I'm not going to go in detail without the data. Tomorrow, we are going to explain with the data set. As a part of theoretical part, right now, mean value is 0. Let me put it. Just take for example, this mean is 0 means here, for example, annual package 75,000 rupees. Here I'm going to put 75,000 rupees. Here in this particular point, mean is equal to median is equal to mode. Means 50% of your data is left side, 50% of your data is right side. I'm just repeating again. When you're talking about average, average means mean value. Means an average, your GNLU students, they're getting around 85,000 rupees. Here I'm going to put 85 or 75, whatever the figure it is. Here I'm going to put 85,000 rupees here. Now I'm also have -1, +1. These are all called standard deviation. Means how much we have 50% of the data left side, 50% of the data right side. Now with -1 +1, that is one standard deviation. It means 68% of your data is falling with -1 standard and +1 standard deviation. So I'm going to see based on the mean value, the difference between -1 and +1. Is it 10,000 difference or 20,000 difference? So 68% of your data. So basically you try to understand how your data is falling, what are the data that you collected it. So if you can wait till tomorrow, we are going to have the hands-on practice with the test, we are going to discuss about it. Now, the last point that I want to highlight here is that, as you can see that middle part is the mean value, this is the average value. It indicates mean is equal to, median is equal to mode. Second point here, 50% of data is falling left side, 50% of the data is right side. When you talk about one standard deviation, it means 68.2% of your data. 68.2% of your data, roughly 68% of data is here. One standard deviation. 95% of the standard deviation, that is -2 +2. So we can able to see that 68, 70, 95% of data is falling here. Remaining 100% of data is coming here, like my 2.5 coming here. This is the overall understanding of normality curve. If you're not getting normality curve, there might be some problem with the outliers. With the help of the skewness kurtosis and with the help of normality test, tomorrow I'm going to discuss with clear, with more explanation on it. Okay, let's go to the next part. We have discussed about levels of measurement, like we also discussed about random sampling, normality test. One more important point, the normality test, we're not going to use it for all types of variables. Normality test, we're not going to use for ordinal data, nominal data. We are going to test normality only for quantitative data. If you have interval data, ratio data, only in that case, you are going to go for normality test. If you have categorical data like nominal, ordinal, is not required and is not possible to conduct normality test for that categorical data. Okay. Next one, independence of observations. This is the most basic common test. Every test means I collected data from Viral Mandia, Dr. Viral Mandalya, and I cannot use same data for the other person respondent. So every respondent is unique. Every respondent is unique for me, right? So I need to see the observation, the kind of data point that I have it, they are independent of each other. So this can be taken care by the researcher at the time of data entry, at the time of data collection, especially data entry time, data analysis time as such. Okay, one can able to see that a lot of manipulation that is not right of right now. We are not going to discuss about it. So these are the basic assumptions for any statistical test. Take it comparison based test, t-test, ANOVA, regression, correlation. I'm saying these are the basic, means there are more than this, we have so many other assumptions we have it. All the assumptions depends on type of the test that you're going to choose for it. So we have data, we are able to understand two types of statistics, inferential, descriptive. Within inferential, we have so many tests, but we also understood that we have parametric, non-parametric. Imagine that you fulfill certain assumptions. Whether you're fulfilling the assumptions, you're not fulfilling the assumptions. If you're going for inferential statistics, whether it's parametric statistics, whether it's non-parametric statistics, one has to go for framing the hypothesis. Generally, people will ask, why you don't have hypothesis? It is very difficult to justify, it's very difficult to convince some of the people. If you are not having hypothesis in your research proposal, they will blame you like anything, right? But the problem here is that, what is the purpose of the study? That is very important, right? Now, as you all know that what is meant by hypothesis, it is a tentative assumptions. It should be in the form of a testable format. Most of the times, if you see many of the scholars, they used to come hypothesis in the form of a paragraph. In addition to paragraph, they also give conclusion. They'll also give conclusion saying that, okay, this is my hypothesis. Hypothesis should be in the form of testable format, means as a researcher, if you're framing your hypothesis, there should be scope for going for further studies. If you are submitting your proposal and you're framing hypothesis, means you're going for conducting a study. But if you're giving conclusion as a part of your hypothesis, it means what is the point of writing hypothesis? What is the point of submitting your proposal, right? So whenever you're framing the hypothesis, one has to ensure that it should be reasonable. Is there any logic? Is there any reason? Are you trying to look at the comparison? Are you trying to see relationship? Are you trying to see cause and effect relationship? So your hypothesis will tell you what kind of statistical test we are going to use. What I mean is to say that by looking at the title, looking at your hypothesis, scholars can tell whether the scholar is going to use t-test, ANOVA test, regression test, correlation test. We don't need, scholars no need to see the research findings, research report. Looking at your hypothesis, one can able to tell what kind of statistics that you're going to use it, right? Now, when it comes to the sources of hypothesis, as you can see right side, generally we frame hypothesis based on the existing literature, based on our understanding of the existing literature, based on the theories. Here, I also wanted to tell one important concept here. It's nothing new. Let's take, for example, generating hypothesis, generating the hypothesis, testing the hypothesis. Now, as a part of your research, the main purpose is testing the hypothesis or developing the hypothesis. Now, if my purpose is testing the hypothesis, I'll take the help of existing literature based on my understanding on the research gaps, research literature that have gone through that. I'll come up with various research hypotheses. I'll also choose theories. It may be, name it based on your background that you're coming from. Economics, statistics, sociology, social work, whichever background, management background. So we have various theories. If you want to test the particular theory, you're going to come up with your hypothesis. Basically, you want to see whether are you going to check what is the validity of this particular theory, or maybe you want to look at the current generation, current situation. You want to add any new knowledge, new variables, new concepts, or other way that you want to generate the hypothesis, means you want to develop the theory. I'm sure as a part of qualitative research, I'm going to discuss about on 10th day is going to be theoretical part about basic understanding of qualitative research approaches like grounded theory, phenomenology, very briefly, not in thorough manner. Now, as you all know that grounded theory, phenomenology, for example, phenomenology, the main objective of phenomenology is to understand the lived experience of the people. If I want to understand the person who is suffering with breast cancer, right? I just want to understand the experience of a person with breast cancer. If I want to understand the person with disability, if I want to understand the person who is having some kind of discrimination, some kind of inferiority, or maybe depends on the organization. So if you try to understand certain experiences, if you want to explore, and you want to develop the theory, one can able to do that. Now, there is a difference. One is generating the hypothesis. Second one is testing the hypothesis. As a part of the qualitative research, one can develop the hypothesis, one can develop the theory, one can able to come up with certain presumptions, certain propositions as an outcome of your qualitative research work. Whereas as a part of quantitative research, you are going to test your hypothesis. Now, when to frame a hypothesis? Basically, we frame a hypothesis in the early stage of our research. Once we complete your literature review, we'll get a lot of confidence, a lot of clarity. What is the scope of your research is all about it. What is the basically this particular hypothesis, it gives you scope, direction. Otherwise, what happens is you'll collect the data whichever is not required for you, and the examiner is going to grill you like anything. Now, if you have certain hypothesis, look, this is my research objectives, these are my research hypotheses, these are my limitations of my study. Nobody can grill you, right? So your remote is going to be there in your hand. But if you want to give the scope, and if you're not coming with proper hypothesis, proper research questions, then that's all. I'm sure as many of your professors, many of your scholars, you know, as based on your experience, what kind of work can take place. So as I mentioned it, hypothesis must be in the form of logic. It must be in the form of testing the variables. It should not be in the form of conclusion format. It should not be in the form of conclusion format. Just for the sake of a small exercise, imagine that you're working in one national zoo park. One of your responsibilities is to feed the monkeys. And there are 5 types of leaves, A, B, C, D, E. There are 5 types of leaves, A, B, C, D, E. Now the question is, your responsibility is to feed the monkeys. Now, before feeding the monkeys, you want to conduct research, you are framing the hypothesis. Now, there are 3 types of hypotheses we have. Now, I just want to know from all the participants, what is the correct hypothesis? What is the first, second, third? Which is the correct one? Third one is the correct. Okay. Next. Second is the correct, Dr. Swati. Second. Third. Is there anyone says the first one is correct? Now, the problem with the first one is that you are able to frame hypothesis, but you're also giving conclusion. Okay, so it cannot be the right hypothesis. Third one, you are framing the hypothesis, but it's vague. You're not able to tell exactly which is the right leaves they are going to eat. You're not predicting anything. You're saying that preferably they eat whichever they like the best. Means you're not predicting something that they're going to eat A leaves, B leaves, B leaves. So in that case, the second one is the correct one. There are different ways how one can frame the hypothesis. Now coming to the last part, how to conduct the statistical test. Now, as a part of the test, we have null hypothesis and alternative hypothesis. Null hypothesis and alternative hypothesis. Simply put it like this, null hypothesis, basically you put it, there is no difference. For example, if you're looking at the difference between males and females, you're saying that both are equal. There is no difference. There is no association. There is no cause and effect relationship. So basically, you start saying that both are equal. There are no differences. There is no comparison. There is no significant association. There is no significant difference. Whereas when it comes to alternative hypothesis, we say that there is a significant difference. There is a significant association. There is a significant cause and effect relationship. Right? So these are 2 different ways. We also have one-tail test, two-tail test, and directional hypothesis, non-directional hypothesis. There are different kind of ways one can frame the hypothesis as a part of this test. Now coming to the last part, there are 5 steps one has to follow if you want to test your hypothesis. First one is framing the null and alternative hypothesis. Like there is no difference between male and females. There is no association between male and females. Second one, very important point, level of significance. We have 3 choices. We have 3 choices. One is 0.05, second one 0.01, third one 0.001. Now, as a researcher, we have 3 choices. I can say that instead of 3 choices, it depends on the background from you are coming. For example, if I'm coming from management, or if I'm coming from social sciences. If I'm coming from social science, I'll go with 0.05. Means as a researcher, you are putting 100% effort, but there is going to be a margin of error of 5%, right? You might be correct, you have taken all the precautions, but still there is a scope, some kind of error can take place. If I'm coming from health background, if as a medical scientist, for example, if I'm a scientist working on some drugs, Covishield and Covaxin. If I tell Dr. Kalpesh, I'm 5% confidence, I'm 95% confidence, this particular drug that I came right now is very good. Means there is a 5% risk. We can't take the risk 5%, right? Right now, we don't know what is happening yet. So generally, the scholars, those are coming from health, scientists, medical scholars, they'll go for 0.001. Now, the point here is that if I take 95% confidence interval, it means, as you can see my cursor, my screen here, this is the 95% of my confidence interval. It means if the p-value, there is one more concept called p-value. Let me talk about it. Right now, what I was seeing here, this is called 95% of my data. 95% of my data findings. Remaining 2.5%, 2.5% here. It depends on one-tail test, two-tail test. If I'm going with two-tail test, means if I'm going with, there is no difference between male and females. If I'm not giving any particular direction, like increasing, decreasing, I'm simply saying that there are differences. It can be left side, or it can be right side. It can be increasing, it can be decreasing. It means if I'm not giving particular direction, it is going to be a two-tail test. Just because we don't have much time, I'm not able to discuss it as I have to go for question answers. We have a concept called directional, non-directional. It is also known as one-tail test, two-tail test. Directional hypothesis means you are giving particular direction, means I'm saying that the children's, those who born as a premature babies have low IQ than general population. Means, for example, if you take gestation stage, roughly I'm going, let's take for example, 38 to 40 weeks is a basic gestation, like a delivery stage, right? Now there is a possibility that premature babies and post-mature babies. Premature baby in the sense like 34 weeks, 36 weeks, right? Now, if I'm saying that the babies born, premature babies have low IQ, means I'm saying that low. Or if I say lesser, or if I say decreased, means I'm giving one direction. This is called one-tail test. This is called directional test. But in case if I say that there are differences between premature babies and general gestation babies, means I'm not saying the premature babies have low IQ or high IQ. I'm saying that there are differences. With the help of the test, I'll come to know whether premature babies have equal IQ score or lower IQ score or higher IQ score. Now, if I am going for non-directional, if I'm not giving any particular direction, that is called two-tail test. It means here it is going to be 2.5, here it is going to be 2.5. In between, it is a 95% data. Now, what are the tests we are going to conduct from tomorrow? What are the tests that we are going to conduct tomorrow? If the test result is going to be part of this particular region, this is called critical region. This is called critical region, 2.5, 2.5. If my data falls within the critical regions, then we are going to come up with, we are going to reject the null hypothesis. We are going to take the call like this. Critical value divides the distribution graph into acceptance and rejection region. If the value of the test statistic falls in the rejection region, that is, if the value falls here, 2.5, this is from here to here, 2.5. If my test value, what are the p-value, what are the test, for example, t-test, regression, correlation, if the value falls here, what is going to happen? If the p-value of the test statistic falls in the rejection region, then the null hypothesis is rejected. Otherwise, it cannot be rejected. Let me put it like this. I thank this particular scholar, nicely presented this particular data. I hope it will be more clear to you. More than my explanation, this particular image will give more clarity. Let's take, for example, if I say the two-tail test, 2.5, 2.5 here, okay? This is called critical region. This is called critical region. If my p-value falls in this critical region, I'm going to reject my null hypothesis. If it comes here, I'm not going to reject my hypothesis. Fail to reject the null hypothesis. I'm going to conclude if the critical value tomorrow, if you can wait till tomorrow, with the help of the data, we are going to have more understanding about it. Right now, if you're going with a two-tailed test, that is a non-directional hypothesis, one has to see both the sides critical region. Okay, like as you can see here, minus 2.5 plus 2.5. If data falls, what are the test results that you're going to get it? If it falls within the critical region, we are going to reject our null hypothesis. If it falls before the 2.5, that is 95% confidence, you are going to say that the researcher failed to reject the null hypothesis. We are not going to say that we are accepting the alternative hypothesis. We are going to say that the researcher failed to reject the null hypothesis. Okay. Now next, so we have a number of options. We have it. One tail test, left. This is called right. Whether it is right or left, this is called one tail test, and this part is called one tail test. It can be right side, it can be left side. Whereas this one is two tail test. This is also known as non-directional hypothesis. This is called directional hypothesis. It can be left, it can be right. So these are the values we are going to take based on the confidence interval, based on the level of significance that you have taken it. Based on that, we are going to look at the critical value, test value. We are going to look at here in that part. Okay. Come up with our conclusion part. How one can able to interpret the data? Let's take, for example, this is sample. This is SPSS data set. This is a sample example. Imagine that this is the test we got it. This is a one sample t-test. This is a one sample t-test. Hypothetically, there was a report. That report mentioned that on average, Gujarati people height is 66.5. There was a report published in the year 2023. As per the particular report, on average, Gujarati people height is 66.5. So Gujarat total state is the population. Now I'm working in Gujarat. I just want to conduct the research. I just want to know whether really Gujarati people are height is 66.5 meters. Okay. So I just want to test. So what I did, I just collected data from 2,000 people. So in this case, there are 408 people, including after excluding the degree of freedom, we have 408, 407. I can say the 408 people. I collected data from 408 people. Okay. Now, my value is 66.5. I'm just comparing the sample, that is 408 people, with the population mean. Right now, don't go in detail. Now, the point here I want to explain is that you conducted the test. We got the results here, like t-value, p-value, and confidence interval. Tomorrow, I'm going to discuss every value I'm going to discuss in tomorrow's session. Right now, I want you to focus on if the p-value less than 0.05. Right now, I want you to focus on if the p-value less than 0.05. As it is a two-tailed test, it is less than 0.05. Our hypothesis population value was 66.5. Our population of total population of Gujarat height is 66.5. The average height of the overall adult population in the state Gujarat, based on the data that I collected, 408 people, the test result was less than 0.05. The test result, based on my sample data, the test result is less than 0.05. So it is, where it is falling? As it is a two-tailed test, it is falling here. Now, as it is falling in this particular critical region, what I'm going to conclude? We reject the null hypothesis that the mean height of the students, research scholars at GNLU is equal to hypothesis population. Means as a part of my null hypothesis, I mentioned that there is no difference between Gujarat state and GNLU population height. Whereas with the test results, I'm saying that I'm rejecting the null hypothesis, saying that the mean height of students and research scholars at GNLU is equal to the hypothesis population means. I'm rejecting that as a mean of 66.5 inches and conclude that mean height is significantly different from 66.5. So this is how we are going to analyze, we are going to interpret it based on the p-value that you are going to choose. So as a researcher, the kind of level of significance that you are going to opt, that makes difference at the time of analyzing your research report, at the time of coming with rejecting or accepting your null hypothesis. I'm not discussing more detail. If you are going with Excel, for example, if you are using formulas, we have to by heart so many formulas, we have to learn certain statistics. But with the help of SPSS, with the help of geometry, it's reducing 60 to 70% of our burden. If you know basic concepts, theoretical understanding, then easily one can able to learn it without learning the formulas, without by hearting certain statistics in that case. Okay. So this is the confidence interval, as I mentioned it. Confidence interval. Now the point here is that lower bound, upper bound. Tomorrow, every test that you're going to conduct, it is going to be part of every test. It is going to be part of every test that you're going to have it, lower bound, upper bound. Means as a researcher, I'm 95% confident that there is a difference between Gujarati total population and the students and research scholars, those are staying in GNLU. Their height, there is a difference between GNLU students and research scholars and total population. Okay. Now, I'm also going to say that at confidence level, 95% confidence level, for example, 1.01, for example, let's take for example, as many of you are cricket lovers, I'm obviously, many of you might be liking cricket. Now, Sehwag, Virendra Sehwag, one of my favorite and still is a favorite one. But just I'm comparing it hypothetically, don't scold me. Okay. There is a two batsmen, one is Virendra Sehwag, second one is Virat Kohli. Now, if Virendra Sehwag is going to batting, if I'm going to opt for Virendra Sehwag as the next batsman, there is a possibility that he can score 10 or he can score 300. Virendra Sehwag, 10 and 300 also. He can make 300 also. Next one, we have Virat Kohli. At least I can expect minimum 50 to 100 or maybe even 150 also, right? Now, if I ask some of you, there is a possibility that Virendra Sehwag can make a triple century. He can make 200 double century, triple century also. At the same time, there is also a possibility that he can make 10, 20. Now, the difference between 10 and 300 is 290. 290 means, as a researcher, 95%, I'm confident that Virendra Sehwag can make either 10, between 10 and 300. Means this is very huge. The confidence interval is, I'm not sure exactly how much you'll score it. So there is no exact consistency. There is no exact, I can't rely completely on him. Now, when it comes to Virat Kohli, there is a possibility that he may score at least 50. 50 is guaranteed at least. Now, whom you choose right now in this particular case? I'm saying that I'm confident, 95% confident. Let me put it for the sake of simplification. For the sake of simplification, 50 to 70. I'm not expecting more. 50 to 70 difference is hardly 20. Means he may score 50, he may score 55, he may score 70 also. The scale between 50 to 70 is hardly 20%, 20. Whereas the difference between 10 and 300 is 290. Now, let's take, for example, this data right now. On average, Gujarati, the people, those who are studying at Gujarat National University, especially research scholars and students, their average height, there is a difference between total Gujarati population and GNL students population. But how much difference is there? 1.53 means total Gujarati population mean height is 66.5. Whereas when it comes to GNLU, their height is 68, somewhere close to 68. Means there is a difference of 1.53 mean difference is there. There is a 1.5 of 1.53. There is a difference between total Gujarati population and GNL students here. Okay. Now, it is a mean difference. 95% confidence that there is a difference of 1.53 between total Gujarati population and GNL students. The plus point of 95% confidence interval is that though there is a difference 1.53 at 95% confidence interval, at lower bound means there are people 1.01 lower level. Though I'm saying that 1.5 is the mean difference between population mean, sample mean, but lower level, I can go, for example, when I talk about Virat Kohli, imagine that difference is coming here around 55 or 60. Lower bound is 50, upper bound is 70. Means right now we got 60 mean difference. Lower bound score is 50. Means there is a possibility that Virendra Sehwag can score 50. At least minimum 50 he will score. upper bound means there is a possibility that he may score 70 also. So that is the confidence interval is all about it. So I think this is all I can able to put it in a layman point of view. Next, Dr. Pondaranga.
Let me thank you for giving me opportunity to attend your lecture. It was very wonderful, and it was, you have explained very simple way that everyone can understand, because statistics is an area that people do not understand, even they attend multiple sessions, but it was very nice.
Next, Professor Afreen Begum.
That my data type is quantitative and the sampling type is stratified. On the basis of these two only, if I go in deep, my data is not distributed in some variables. What to do?
If your data is distributed not normally, there are two options. Just look at your sample size. Imagine that your sample size is large, big enough, good enough. Try to see the outliers which are disturbing your normal distribution of the data. If your sample size is good enough, if you can able to highlight, if you can able to look at the outliers, remove that outliers. Okay. If your data sample size is good enough, big enough. Okay. Otherwise, what you can do, second option, you can increase your sample size. If you don't want to remove any outliers, if you don't want to remove that particular respondent, you can increase your sample size. These are the two options. Third option, if you can't do whatever I mentioned right now, option 1 and option 2, you have to go for non-parametric statistics. Critical value test.
Yeah, but it's for quantitative data. Okay.
Hello, sir. Am I?
Yeah, please go ahead, ma'am. Please go ahead, ma'am.
Sir, first of all, again, as I said, the others were also mentioning, I would like to thank you from the bottom of my heart, because you explained the lecture in a very simple and easy language. Sir, my question to you is, you mentioned that if the data is related or telling something in one direction, we use one tail test. So can you give me some example where we can apply two tail test?
Okay. I'll explain it. I'll show you if my slide is there with me. Otherwise, I'll give an example of premature babies that I mentioned to you. Yeah. So this is called one-tail test. Now, when it comes to the whether it is one-tail test, whether it's two-tail test, whether it is directional, whether it is non-directional, you are going to see the difference in alternative hypothesis. I'm just repeating again. Whether it is one-tail test, whether it is a two-tail test, whether it is directional hypothesis, non-directional hypothesis, you are going to see the difference in alternative hypothesis. For example, right now we are seeing the slide one-tail test. Now, if you look at this one-tail test null hypothesis, the children born prematurely have mean IQs that are not different from those of general population. Okay, this is null hypothesis. Coming to the alternative hypothesis, children born prematurely have lower mean IQ, means you are saying that you are giving some direction, lower, higher, increasing, decreasing, greater or smaller. This is called directional. Okay, this is called directional hypothesis. This is called one-tail test. Now, coming to the second, look at the alternative hypothesis of two-tail test. Children born prematurely have IQ scores that are different from children from general population. Means here, for the sake of your understanding, for the sake of participants' understanding, I just mentioned in bracket either lower or it can be lower, it can be higher. But I'm not saying like previous one, lower IQ score, higher IQ score. I'm saying that simply they are different from children from the general population. Means I'm not giving any direction here. So it can be a two-tail test. It is going to be non-directional hypothesis. You got the point, madam?
Yes, sir. It is very clear now. Thank you so much.
Please welcome. Thank you. Next, Professor Soumya Wadvi. Professor Soumya. Professor Leena. Yeah, Professor Soumya, please go ahead.
Yeah, this is the second session I'm attending. Your teaching method is very wonderful and very simple. You are teaching and it's very wonderful. Sir, my question is, my research is a mixed method of a research. So how to proceed with the quant and the qualitative data? If it is an exploratory study, then how we can decide a sample size in a quantitative?
Sample is completely different, ma'am. As a sample
Okay,
size.
then if it is a mixed method of research, then whether we need to proceed first initially with the qualitative, then quantitative, how it will be?
See, in mixing method, we have different types. Okay, there are so many types we have it. Broadly, let me put it in 3 types. Let me explain broadly. Exploratory, like for example, sequential design, concurrent design, integrated design. Within sequential, we have 3 types. Within concurrent, we have 3 types. Integrated, we have different types. Based on the type of the state, how you're going to collect the data. Based on that, you can have mixed methods. We have different types of mixed methods that cannot be explained right now, but we have sequential, we have concurrent, we have integrated mixed methods, all we have it. Now coming to the sample size, if you're going for quantitative, that if you want to go for inferential statistics, we should have some good sample size. It depends on the total population that you have it. There are certain parameters. We have one software. Name of the software is Rao Soft. I'm not the person. Professor Rao is very senior, recently passed away. He also awarded with a Nobel Peace Prize for his contribution in the area of statistics. He came up with very nice statistics, nice software. I'll also share with you all via email or tomorrow session. Link I'll share the. You can calculate the score. You can calculate the sample size by using the online calculator. We also have certain conventional, traditional methods, how one can determine the sample size. So I can't cover right now, but this is what you can able to do that right now. Okay, thank you.
Thank you, sir. Only the thing is whether there is any interconnection between qualitative and quantitative while selecting sample, or whether we need to go with only sample size calculation.
Let me put it like this.
बोल दिया ना कर दूंगा कर देता हूँ
I request the participants. Please check your
Guleria,
mic.
Satish Guleria, please keep your mic muted. Satish.
See, if you're not able to keep your mic.
Sorry, no, please, I suggest you keep mic muted because it is very difficult.
I request other members, please write down your questions.
Yeah, it's
in the chat
really.
box. Write down your questions in the chat box. In the meanwhile, I'll start answering the questions. Professor Rahul, thank you so much for giving the calculator here. Now coming to this, what was the question? Sample. See, one point I want to conclude with that, with a reference to your question. Being a qualitative researcher, here I'm not here to generalize my findings. I'm least concerned about my sample size. If I'm going with phenomenology, if I'm going with grounded theory, if I'm going with ethnography, autobiography, the more of my interest is here is to explore, discover, come up with a theory. So I'm least concerned about sample size as a part of qualitative research. Whereas when it comes to quantitative research, if I'm going for inferential statistics, the main objective here is to generalize my findings. So I need to see what is a representative sample size that I'm going to talk about it if I want to generalize it. So in that case, one has to go for normality distribution, where are certain assumptions that I mentioned it. Madam, you can wait till end of quantitative data analysis. Definitely you'll get some clarity. Otherwise, please ask me once again on 9th September. Still, if you're not getting clarity after completion of certain modules, certain concepts as a part of quantitative data analysis. Okay. Next, are there any questions in chat box? Shall we end the session? Miss Vinny Singh, could you explain probability, non-probability sampling and its connection to parametric, non-parametric? Probability sampling means each and every respondent is having equal chance of being selected. For example, there are 500 participants. I can take any name randomly. I can ask, please unmute yourself and ask me the question. Out of 500 participants right now, those are here. I want to select 50 people. I can choose anyone. For example, if I'm asking Dr. Kalpesh, choose randomly any 50. Means serial number 1 to serial number 5, and serial number 500. Every participant is having equal chance because randomly we are picking it. Nobody knows whom Kalpesh is going to take because he's just looking at the numbers. Serial number 1 to serial number 500. He can pick anyone. Means everybody's having chance of being selected. So as a part of probability sampling technique, we have simple random sampling, stratified sampling, for example, stratified. If you want, for example, Kalpesh, out of 50, you want to choose 25 people male, 25 people female, or for example, you also want to select transgender. So you can differentiate 33%, 33%, 33%, that way also. So we have stratification. We also have systematic sampling. There are a couple of sampling techniques, systematic sampling. We also have cluster sampling. Like for example, I'm collecting data from all over India. So what I'll do initially, I'll see that 5 zones, north, east, west, south, and then developed district, underdeveloped districts. From each district, again, I'll go for 5 villages, talukas. So there are geographically, I'm classifying. So it's going to be cluster sampling. So all these are coming under probability sampling technique. Basically, whether it is a simple random, whether it is stratified, whether a cluster, whether it is a systematic sampling, you are going to choose your sample randomly at the end of the day. At the end of your choice technique, you're going to choose randomly. This is called probability sampling technique. Whereas when it comes to non-probability sampling technique, it means we have some criteria. Let's say, for example, I want to collect data from the person who has experience of using AI tools. Or I just want to collect the data from the, for example, I'm sure all of you might have seen Mahendra Singh Dhoni, right? For many of you, for many of us, he's an inspiring story, starting from his journey. Now, as we already watched his movie, many of us watched his movie, one can able to see that what are the faults, what are the problems he faced it. So it is basically narrative. Basically, I just want to collect data from people like Mahendra Singh Dhoni, or maybe good, successful entrepreneurs. Not only their success, I also wanted to see their failures. What are the challenges they have faced it? Means he's the right person. Let's say, for example, I want to collect data from Dr. Kalpesh Kumar Gupta, having experience of 15 years, having launching 5 to 6 startups. He can be a good mentor. Looking at number of failures, challenges, he's the right person, can give me, okay, this is what we have to go, this is how we can go ahead with that. Now, I'm going to choose so-and-so is my respondent because based on the experiences, I have certain inclusion criteria, certain exclusion criteria. So this is called purposive sampling, it's called judgmental sampling. So this is all about non-probability sampling. There are so many things. This is out of the context right now. I can't discuss much. So this is all about today. Shall we end the session? Are there any questions? Last 1 or 2? Tomorrow we are going to discuss about how I'm going to share with you all Jamovi link, and we are going to install it. If you can able to install it, well and good. First 5 to 10 minutes tomorrow I'm going to discuss, and tomorrow we are going to talk about interface of Jamovi. What are the features of Jamovi? This is all we are going to discuss about. Thank you so much.